21 million more reasons to buy Bitcoin. Here are 10 ironic aspects of Bitcoin mining and hash power when compared to regular computing with some detailed explanation. The first one is energy consumption and productivity. Bitcoin mining consumes massive amounts of electricity to solve cryptographic puzzles, yet it produces no tangible useful output beyond securing a network and validating transactions. Regular computing, like running a video game or rendering a movie, uses energy to create something perceivable or functional for user. The irony lies in Bitcoin mining rigs churning through terawatt hours of power annually, enough to power small countries, while the end result is just a string of numbers or hashes that might win a block reward with no direct utility to the average person. Now let's look at hardware specialization over generalization. Regular computing thrives on general purpose hardware like CPUs and GPUs, designed to handle a variety of tasks from browsing to machine learning. Bitcoin mining, however, has shifted towards ASICs, or or simply called application specific integrated circuits, which are hyper specialized for one thing: hashing SHA-256. The irony is that these machines, despite being technological marvels, are essentially useless outside of mining Bitcoin, unlike a regular computer, which can adapt to countless applications. The next one is decentralization powered by centralization. Bitcoin's ethos is decentralization, yet the hash power securing it is increasingly concentrated in large mining pools or industrial scale operations. Regular computing is often decentralized in practice. Anyone with a laptop can contribute to a project, while Bitcoin mining hash power lies in how distributed network relies on a handful of powerful players who can afford the hardware and cheap electricity, subtly undermining the original vision. Or is it so? Value creation through wasted effort. In regular computing, efficiency is king. Developers optimize code to minimize resource use. Bitcoin mining flips this on the head. Its proof of work system rewards inefficiency as miners compete to burn most computational power to find valid hash. The irony is that the waste is the backbone of Bitcoin's value and security, while in regular computing such inefficiency would be deemed as failure. Heat and byproduct heat as a byproduct, not a goal. The regular computing treats heat as an energy. Cooling systems are critical to keep CPUs and GPUs running smoothly. Bitcoin mining produces enormous heat too, but miners often see it as a mere byproduct, sometimes repurposing it for heating homes or greenhouses. Irony is that mining rigs can double as heaters with no loss of their primary function, while regular computing would grind to a halt if you try to use its heat output that way. Hash power arms race versus stable performance. Regular computing hardware improves incrementally, and users need not need the latest gear to stay functional. Your 5-year-old laptop still works fine for most tasks. Bitcoin mining, however, is an arms race where hash power escalates rapidly. The older rigs quickly become obsolete as the network difficulty adjusts. The irony is, miners are forced to constantly upgrade, not for better features, but just to maintain their slice of the reward pie. Silent work versus visible results. When you use regular computer, you see results: document typed, games played, websites loaded. Bitcoin mining's hash power operates in the background, churning out trillions of calculations per second with no visible progress unless a block is mined. The irony is this silent, relentless work is what keeps Bitcoin alive. Yet it feels abstract and detached compared to the tangible feedback of regular computing. Profit motive over problem solving. Regular computing offers aim to solve real world problems, think specific simulation or data analysis. Bitcoin mining hash power, however, is directed solely at profit, finding next block to claim BTC rewards. The irony is that immense computational effort could theoretically tackle complex issues, but instead it is locked in single purpose economic game, which is what is needed in the present world with the present issues that we are having with our financial system. Network security through redundancy. In regular computing, redundancy is often a flaw. Why run the same tasks twice? Bitcoin mining hash power thrives on redundancy. Millions of rigs worldwide perform the same hash calculations with only one winner per block. The irony is that wasteful duplication of what makes Bitcoin's network secure against attacks, turning a computing sin into a virtue. Immutable ledger by constant change. Regular computing values stability. Once a program works, it stays that way unless updated. Bitcoin mining's hash power, however, is in constant flux with the difficulty adjustment every 2016 blocks, roughly every 2 weeks, to keep the block time steady at 10 minutes. The irony is that this ever-changing computational landscape ensures blockchain's immutability, a fixed record born from relentless adoption.